to OLI Systems. So Felix, maybe you can start and first of all present yourself, and then we'll go from there.
All right, thank you so much, Natalia. Yeah, hi, nice to meet you. We are OLI Systems. My name is Felix Förster. I am system engineer here at OLI Systems and in charge of the blockchain labs. And here's my colleague Thomas Brenner, our CTO. And we will now take a look at our slides. We prepared for you 25 slides, so not that much. Don't worry. I hope this works now with the first try, hopefully.
It works.
I hope you can see now something. Full screen. For the introduction, my colleague Thomas Brenner will tell you a bit about our general ecosystem. And afterwards, we'll go a bit more into detail with the blockchain app. So I will now give my work to Thomas Brenner.
Yeah, thank you again for hosting us. And yeah, basically, as Felix said, I think we will structure it twofold. So first of all, I'll say a little bit about what we do, why we do that, and then just give you a quick overview on the different cases that we're working on, and then basically I'll hand over to Felix, and he'll dive deeper into like how basically the entire steps, say from energy asset to blockchain market really works, and how so which elements basically are involved and how we actually do these things. So first of all, let's see. As I said, I'll briefly introduce the concept and ourselves. Then we'll dive into really the use cases that are there, and finally we will have mainly, I would say, two prominent examples or different examples also of implementations of what we call blockchain labs. So who are we? We are a startup founded in 2016 in Stuttgart. So OLI Systems basically emerged out of a energy consulting project, basically that we were doing, and soon it sort of became obvious that we shouldn't produce more paper, let's say pragmatically, but we should really have a look how we can manage those decentralized assets that popped up and still pop up all across Germany, but also I would say worldwide nowadays, with small PVs, small CHPs, heat pumps, charging points, and so on, because simply the amount of devices that have to be integrated into the energy system keep growing, and the diversity keeps also growing. And so we basically came from that perspective and said, oh, look, this is not something that you solve with conventional tools that are generally used in the energy sector. And soon thereafter, basically, we stumbled across the first trials that had been done more on a sort of, I would say maybe hobby basis is too harsh, but on a very preliminary stage in terms of doing energy stuff with Ethereum, I would say. And basically, in 2016, we started looking into kind of this concept of distributed IT for distributed energy. I would say we started to look deeper, and from then on, we sort of refined our knowledge. Also, we refined the business model a bit. I'll say a few more words about what we actually do on the next slide. But basically, what we believe, and this is also why we are part of the Energy Web Foundation, is that first of all, this is not something that the whole project of making the energy system more efficient and simply more prepared for this transition is not done alone. This has to be done together with different stakeholders, with different players, grid operators, software companies, etc. And we can't do it alone. So this is a primary driver where we say it's basically useful to work together in this sense, and also to create use cases together. The second thing is, as you can guess, as a startup, it's simply not possible to do everything on your own. And we believe that within the EWF, we have a strong network of partners that allow us not only to test things, but also to develop things together. And that's one of our key goals that we have. So that brings me to the next slide. So what do we cover? What do we actually do? Usually we structure this into like 4 sectors that we believe need to be covered when you try to really carry out a blockchain in energy project. And as you can see, if I start at the bottom, it's always about mastering, not necessarily fully understanding, but mastering the core technologies. And in our case, it's of course Ethereum, it's EWF technology that we're using, but also, and that's usually important, and also a bit underestimated sometimes, it's about the integration of the actual energy hardware into the system. So as opposed to the financial sector, as you know, we are always dealing with real assets, real energy assets, be it consuming or producing assets. But in the end, we need to integrate this hardware. We need to measure, or in a second stage, even be able to control it. So it's really, that's, I would say, a fundamental difference to other sectors where blockchain is gaining importance and gaining traction, is that for the energy sector, it's always about information, but also about electrons. So yeah, just as a general point that shouldn't be underestimated. On the other side, on the left side, of course, it's smart contract development, and that's basically something, I would say in simple terms, it's translating a problem in the energy sector into something that can be run on a blockchain. So how do I implement, and that brings me to the top, how do I implement customers' use cases such that in the end a blockchain system can, I would say, digest them or really actually bring a benefit to the customer. So basically, if we go from really the start, how usually a project starts with us, it's really starting with an idea or a potential use case at the customer, not taking something off the shelf, as you can guess, but really developing the project to some degree also with the customer, and then basically looking into our sort of toolbox of smart contract development, about hardware, about customer interfaces, to see sort of which elements we need to implement a certain case. You'll see a few examples later on, but just to keep in mind that for us, it's always to a certain degree, of course, that varies across use cases, but these 4 elements, I would say, are always involved when it really comes to doing stuff in projects. We've been concentrating on, I would say, 4 use cases in the last 2 years mostly, and I don't think I have to go in full detail because this is more something that you can really go in deeper if you wish. The one project is closely linked to the work that EWF is doing on certificates of origin, because yeah, obviously that's a strong case with a lot of potential, or with a lot of problems that are inherent in the current system, where blockchain can actually simplify things and also make the process much more direct than it is now. In Germany, for example, it's a rather I would say, not old-fashioned is probably too harsh, but it's a rather tedious and also not very customer-friendly system that we have when it comes to actually showing customers that they really have renewable electricity coming out of their sockets. Then the second part we are currently ramping up is activities in the field of electric vehicles, and we look at that perspective mostly from the grid side. So we're really mostly concerned with the problem how to manage charging points such that the grid requirements, especially in areas where grid reinforcement is not an immediate or not a financial option for the grid operator, where we can nevertheless sort of ensure that a sufficient charging infrastructure can be deployed. Third point, and now it gets very technical for people from the energy sector, is what we call OLI balance. That's a project where we try to improve balance group management. So basically keeping the sheet of purchased electricity and sold electricity neutral, and helping balance responsible parties to reduce that. There's a few more slides coming on this, so I won't spend too much time here how it actually works, or how we envision it to work in the final stage. And on the fourth point is the blockchain lab, which is basically what I just explained, and what we will see in the next slides is how do I actually learn as a utility or as an operator of assets, how do I learn to integrate blockchain into my business and into my business models. Certification of origin, as I said, is one of the projects, and what we did now is actually looking at this more from a customer-centric side. So basically, we thought, why is it not possible for a customer to see, like in a mobile phone bill or in a landline bill, to see what my actual sources of electricity are? In Germany, the current status is that once a year you get a bill, and this bill includes a pie chart. And if you're lucky, this pie chart includes the sources that your provider has been basically buying on your behalf, which is far from the actual usage of even individual assets. So basically, in simple terms, you have no clue where your electricity is actually coming from, and from which sources it is. Of course, this is, as we believe, an ideal playground where we can bring blockchain into play, because we can record consumption at the individual household or at the industrial site, and we can simultaneously track the production in decentralized assets, and really bring this together, such that basically now, Felix will show a few details later on this, users of such a system can really see at which time even they are supplied by a certain unit or not. So that's something really we believe is valuable on its own, but as you can see in the center of the slide, we believe these high quality data, especially in the distribution grid, can be very, very helpful also, not only for just giving giving a better customer experience, but also help grid operators, for example, improving their planning, or as I'll show, improving the management of balance groups, which is really significant, or is a growing problem that's already now, at least in the German sector, causing a real financial trouble, I would say, for the parties involved. The foundation of all those use cases is something we have put down on a website that's publicly accessible, called onchain.com, and Felix will now explain a little bit on what you can see there. It looks quite packed, but I think it's a very useful, instructive way of showing basically what all blockchain use cases start with when we do those. So Felix, you can have a go.
Yeah, sure. So what you now can see is basically our Energy Web3 browser. So what we try to do is build a full decentralized application from front end to back end. And on the top side, you can see this line here. I hope it's readable for you guys. You can also see it on your own desktop if you want to. We have, for example, registered producers and registered consumers. We have a gas price on our chain. So this chain is a test chain. It's just a few nodes, which we have full control over. So this should not be happening, of course, in productive use. We have our block number here and our transactions in the latest block. Now, in a smart contract, we have registered producers and consumers. with certain properties, right? So here we try not to bring in too many details because really it's open to imagination on what kind of properties, what kind of abilities you want to give these individual users. So here we have a name for the user, what kind of device type he owns, the peak power available for that device in case you want to activate its flexibility, for example, the coordinates, the voltage level where it's connected to. So this one is your distribution network. We have location, rural, so we kind of believe that PV power in city areas is more valuable than PV power in rural areas. So there should be some kind of note of this fact on chain. We also have an installation date here in case we need this for some applications. But again, it's really open to imagination what kind of registration details you want to have here. So all this info is available in a very transparent way. It's on the blockchain. You just need the contract address and the API to read this one out. So it's also meant as a web-free geo-browser, as I said in the beginning. When we go down here, we can see some dynamic data too. So in the middle, you see the energy production and consumption per block. So we kind of went here on a block-to-block basis. We have a very clear step-by-step block adding process here. It's POA, every 3 seconds a new block, just as with Turbo. And basically, we just count the energy involved in these blocks at a certain time frame, right? And that's how we kind of get some transparency in this system. And of course, this data could be used for certain other applications. We also have some geo information here. As I said before, we have our coordinates also on chain. These coordinates are being read by our front end, and the front end can actually plot with certain libraries now the fact where this device is installed on your screen. And feel free to look into it if you want to. It's just an example, a demo of what we can do with this technology. And it's the basis for many, many other applications right now. I will now try to go back to our presentation, so bear with me. No?
Just down there.
No, I think I have to stop it actually.
Oh, okay.
Because it's just meant from application to application. So here, I think it's this one. Bear with me. You can see it again, hopefully. I take this as a yes. So,
it works.
It works great. All right, should I continue? Or
yeah, go ahead.
Yeah, and as I told you about, this data can now be used also for legacy systems, right? So the fact of the blockchain is on-chain, but we can also take that data actually into an SAP ICU system to actually make the legacy billing if you want to. So we kind of see that we need to do a lot of flexibility still. Of course, you want to put everything on chain from a blockchain side of view, but right now we are dealing with a lot of blockades from certain parties, and we kind of have to be interoperable here in this kind of sense. Yeah, now Thomas will continue with the OLI balance case.
Yeah, so before we actually before all of you get to see some real devices and some real field tests, let me briefly explain why we believe balance group management can really benefit from blockchain applications. I'm well aware that it's not so obvious, and the reason why we think it's a very useful process to work with is because regulation on how you keep your balance group neutral is not very strict in Germany. So you have a lot of options that you can actually use to keep that balance group neutral. Sorry again, can you to keep that neutral? And we believe that in several ways blockchain can be helpful. First of all, the main problem that balance group responsible parties keep having is that they have to follow a certain schedule, which is usually given by an external party based on what's connected in that balance group, and deviations are penalized with a certain fee. Basically, if after the process has been completed, it's noticed that deviation has happened, the balance responsible party has to pay. So there's a pretty strong incentive actually to follow your schedule. But the main problem is that if you don't know what your schedule is, or what your current consumption and production is in the balance group, you can't really take any measures. So the transparency issue of bringing really data about customers that are usually standard load profile customers or customers that are not frequently metered, to bring those on the blockchain and to use this data for balance group management can already help. In the second step, of course, it's improving your predictions about what's going to happen, because simply you learn much more about those customers than you did before, because basically before there was no information whatsoever on this customer. And third, and that's now, yeah, you can leave it. That's now where we believe there's a USP where only blockchain can help and no other solution, is how to manage this balance group actively. Usually what you would do is you would top down try to control assets in order to increase or decrease generation or production to keep it neutral. However, as you can guess, with the hundreds and thousands of assets, this is not something you would want to do as a balance responsible party. What we believe, and that's something we're currently testing, is we believe that it's much, much easier if the balance responsible party only gives out certain quota for the balance group. Say, in the next 15 minutes, I need a reduction of 2% of the power connected. And then what we will try is to establish a local market between assets connected in that balance group. And they will basically, based on a smart contract, negotiate the prices and the willingness basically to take these actions without any direct control by the balance responsible party. So BRP only sets basically the goal, but is not involved in actually how this goal is exactly achieved. And as you can see, market mechanisms and the way how prosumers, consumers, and generation units really interact with each other is key. And this is why basically we thought we'd give you a deeper look into blockchain labs and how it actually works. But here we would like to have a quick break. If there are any questions now at this stage already where we would say stop you, we were lost or we need more information before we continue. Okay, if that's not the case,
I think we can continue.
Okay, if that's not the case so far, good for us. Then we will continue, and Felix will tell you a little more about the nasty business of connecting actual assets and real customers into blockchain infrastructure.
All right, thank you so much. Yeah, so our fourth big use case is our blockchain lab, which we kind of identified over the last couple of months. So in there, we are basically doing 4 steps. The first one is a use case definition. So we're talking to our customer, trying to help figure out what they actually want. What's their problem currently with the current energy system? So it might be a grid operator. It might be an energy supplier. It might be a labeling company. And we're talking with them how blockchain could solve their issues. By doing that, we also find out what their current legacy IT system actually is. So as you know, the energy sector is not really that far ahead in terms of Industry 4.0 or digitalization in general. So there are many, many things that we need to fix in order to get our project work. So that's when we are setting up our new network for this blockchain lab, for this blockchain system. This consists of hardware installation. So in case we don't already have some kind of metering device on site next to the device, whatever it is, PV, battery, we need some device to read out that little power plant in the end. And we're also running out the blockchain infrastructure. So usually the IT departments of utilities are completely overworked with badly working legacy systems. So we are helping them getting their own node to run and helping them to connect to other nodes and stuff like that. Then we're starting with developing our application. So that means writing the smart contract, the heart of the application, and of course also developing some sort of front end. It might run on a mobile phone, it might run on your PC, whatever it is. And of course, we're also giving people support over the course of the project, which might, for example, go for half a year or 3 months. It really depends on the customer. And we're helping them fix some issues, fix some bugs with their infrastructure, helping them acquire the necessary data from the users or from the market, for example, in case it's a market. So now I want to give you 2 concrete examples about what we're actually doing. So example 1 is a project with Busan. So we started in May of 2018, and here it's basically all about making these old PV parks with thousands of inverters and a few megawatt hours of installed capacity to actually work in a scenario where we don't have easily reachable, easily accessible subsidies, right? So what we're doing here is basically taking up their legacy IT system, which exists kinda, and trying to figure out what sort of data they already have in that intranet, what I would like to call it. So as you can see here, through that internet are already connected a few devices like these PV parks, but also a few batteries. And now we are basically going into the jungle of the intranet and trying to find out what kind of data is available, what kind of resolution does it have, and are there any inconsistencies? And in the end, we have to find out, can we use this data? Can we use the system for our new blockchain application, which is in this case tokenization. So yeah, currently we are again going with the machete to this jungle and trying to find a good way and the best way. And basically, we found out that we have to enable the devices, the on-site devices, for example, a SMA solar cluster controller in charge of thousands of inverters. We have to go to these devices and activate the Modbus, for example, in order to really work with these things. The next project I want to touch now is our Allgäu microgrid we do with the AÖW, the Allgäu Oberlandwerke. And basically, they gave us the task to create a local energy market. It's supposed to be quite decentralized, quite distributed. We want to have a 15-minute trading interval. We want to have an app for the end users. So here we're working really on the household level. So households are trading on this platform. We want to have a Victory auction, which is one of many price mechanisms or market mechanisms to work in this kind of scenario. We want to really empower and enable the end user to choose between different tariffs and having a bit more flexibility. And we want to use a industry-grade POA blockchain. Of course, we took a look at the Tobalaba there and helped them build a Tobalaba derivative. More about that later. So, of course, again, energy sector, we don't really have that many devices installed on site. We don't have communication in any sort. So we have to go to the households and actually install our devices. So in this case, we use the OLI box. It's basically a tuned Raspberry Pi 3B, which we then connect to the digital meter. So in this case, we have meters from the company called Easy Meter. It's a German company, very famous in the southern part of Germany. And we're taking a IR sensor to read out that meter to get the data into our box and then to the blockchain and to our front end. In the middle, you see an example, a picture from another project. In this case, we read out a solar cluster controller. I talked about this earlier with the Workcon project. These are already some sort of communication device, but usually, again, these companies only read out these devices maybe once a day at best with very little data. And of course, for most applications, we need higher resolutions and more data to use with. So here in this case, our OLI box is connected to the solar cluster controller. Then the data goes through the intranet of the company and to our backend and to the blockchain itself. On the right side, another example of an Easy Meter installed in Munich. And here you basically also have an OLI box reading out a digital meter. Now, there's another example here. It can be quite tricky out there, of course. So in this case, it's one household using 3 different meters. 1 meter is for the PV, 1 meter is for the heat pump, and 1 meter is for the actual household consumption. And this kind of scenario is just a regular scenario, really. And of course, also here we have to deal with this kind of scenario. This is a very old installation, as you can see. That means the PV is directly feeding into the grid. So it does not try to get the electrons to the bus of the household. It directly goes to the grid. That's why we have 3 meters here. And of course, the heat pump is also separately measured in case we need to curtail the heat pump. That's possible in Germany already. And yeah, these kind of scenarios are very regular. So I talked now a lot about hardware actually, but what about the blockchain? So for the IOV project, we decided for a Topolava derivative. So we have 3 seconds of block time, 80 million gas limits, so quite a fast chain which is capable of a lot of transactions. And we put 2 nodes on a system of IOV with the help. We have 2 nodes at our infrastructure, and we have 2 nodes at Amway Solutions, which were our partners for the front end, for the app development. And of course, to connect these 2 worlds, this hardware energy world and this IT blockchain world, we're using a light node, a light client on the OLI box themselves, which is just reading out the latest block header and is able to send transaction on its own without any hosted node. But of course, we see the problem here with the OLI boxes. They are, of course, hackable, or they might break in certain conditions or whatever. So we are also working on industry-grade, industry-proof monitoring, metering devices like the Scala Pro from our partner Görlitz AG. And we already succeeded in bringing our OLI box software, that means actual the light client and some other software packages like our MQTT broker and publisher, to this little device. So in mid of November, we will have actually a nice casing with a little stamp called blockchain ready. So then we will actually be able to show you the full device and make some marketing with it. Yeah, about the code, the heart of the application. So in this case, again, we have this Victory market, a Victory auction, as was proposed by AOV. And we really wanted to go all the way in this project. It means as much functions, as much data on-chain as possible. And that means we want to do the user registration, as I showed you earlier, also with olichain.com, directly on-chain, directly in the contract. We want to have our bid aggregation and collection also on-chain. So all the bids from the different devices, from the different OLI boxes are being sent to this contract. We're also keeping track of all relevant parameters for the market for each user, which means stuff like which tariff has he chosen, what's his preferred budget, what's his preferred price. It's all there on-chain. And of course, we need this data on-chain in order to actually have, and actually to be able to calculate the market result with these inputs. And what we did here, because we need a good working front end, is we installed a so-called spectator node, which is just a normal blockchain node, which is basically just keeping track of this little contract here. And this spectator node translates all the happenings inside that contract and around it nicely for a MQTT broker, which then sends the data to our front-end partners, Amway Solutions. So we did not want to put too much pressure with Web3.js or Web3.py to our partners at Amway Solutions. We kind of wanted to provide them with an easy-to-use data layer to actually read out and to plot the necessary data into the app front-end. In the app itself, I will show more pictures later, but you basically are able to see 3-second power values. Of course, these are not over the blockchain itself, would be just too much gas costs. We are using here a MQTT broker, as I said, which is just sending the data directly to the app front end. But the user is able to interact with his account on-chain over this app. So he can set his price, his chosen tariff, his chosen alternate tariff, his chosen budget with this app, which will then result in a transaction. And of course, the visualization of all the market results that are interesting for the user. Again, yeah, I want to go a bit more detail on why on-chain. So we see the problem out there that a lot of use cases are actually relying on a lot of off-chain computation. And that is okay and fine if you do it in the right way, but you very easily lose all transparency if you do that. So if you just do the calculation off-chain and just put the hash on-chain, could be defeating sometimes, maybe in most cases, the purpose of a blockchain. We also see the problem of a market operator in this scenario, because he's an intermediary. He would own all the data. He could decide which one to block, which one not to block, which one to actually deliver data that could help him actually betray the market, for example. And of course, it's a single point of failure. And on the lower level, you don't really want to have single point of failures. But maybe the toughest thing is that you lose the possibility to use a token directly also on chain. You have a friction if you have the market off chain and have to kind of shift the tokens from A to B with a certain API then. So we rather have this market on chain, so we can put a ERC20 token, whatever it is, directly next to the contract, next to the market, in order to have them exchange data, exchange tokens. So in case someone earns some money, he earns some tokens. If he spends some money, he will just lose some tokens. Otherwise, we will need an API to make this token work. Yeah, we also decided again for a classic conventional front end. So blockchain comes with a lot of things that are not necessarily nice to our UX right now, right? So we have a lot of asynchronous properties. It takes a while to mine transactions. This is not really something most people nowadays in this world of smartphones and apps are used to. So we rather have an abstraction layer in between the user and the blockchain, which helps them deal with this new kind of systems. I mean, nowadays you have energy supply contracts. You just pay that much money per month to your supplier, and that's it. And now we have a lot more complexity with like a market like this, and a lot of burden of decision on the end customer. So we don't want to also put him with the usage of light clients, key management, stuff like that. So rather keep it slow, keep it simple here. Yeah, so here's our app. I'm sorry it's in German, but maybe you can kind of see what's going on here. So on the left side, we have our first screen where we can see these 3-second values in Erzeugung und Verbrauch. So it means supply and demand. So these are the 3-second power values where we actually can see, okay, now someone is showering with the boiler on, or now someone is using the hairdryer or whatever it is. And also the current supply of my PV plant. I have my actual energy values here too, and connected to a monetary value. So I actually can see what I have produced today as a monetary value and what have I consumed today as a monetary value. In the middle, you can see the market side of things. So here we have this ability to choose between different tariffs. So it's the solar community, it's green power, and it's gray power. And you can here choose now these different tariffs. And of course, also for the solar community, a bidding price, right? What's that energy worth to me? And this price can then be used for the Vickrey auction itself. We can also set a daily budget, right? How many money do I want to spend maximum on this market today? And I can also choose an alternative tariff in case I have bid not enough money or my budget has run out. I can choose to be supplied with Grünstrom, green energy, or Graustrom, gray energy. On the right side, you can see some data from this morning from 11:45. And now you can actually see per quarter hour, what have I consumed? How much of that is my own PV power? And what do I have to buy additionally? And where did it come from, right? Did it come from the solar community? Was it green power or was it gray power? And now I can actually decide and see what I am consuming, which is very nice for people who are especially intrinsic motivated. All right, thank you so much for your time and attention. You can see our contact addresses here, so feel free to visit us on myoli.com or visit our GitHub repository where we have a lot of applications already uploaded. We're also on Twitter, and on the bottom you can see our names again and our email addresses. So in case you want to contact us, feel free to do that. thank you so much, and we're now looking forward to your questions.
First of all, Felix and Thomas, thank you so much. This was, I think, first of all, you went into so much detail, which we appreciate, and so thank you for that as well. I just wanted to actually say that you're doing such a challenging and beautiful work, and I'm wondering, how many people do you have? How many people are actually working on this?
So currently we are 8 people, 9 people soon. I think on 1st of November we become 9 people. And most of us are students right now, but we also have 4 full-time people. So full-time people try to teach and educate our students right now in order to understand this. Of course, if you work in this sector, you know there are a lot of blockchain developers out there, so we try to teach them and educate them ourselves, and then we just make them full-time people, and then they will become full-time workers.
Great. We have one question that just came in. It says, you said you use a Tobalaba derivative. How does it differ?
So in theory, it doesn't differ at all. It's the same, not the same blockchain. It's the same, how should I say it? It's the same software piece maybe, but it's not connected to the actual Tobalaba. So we take the same block time, we take the same block size, for example, and of course we're also using parity UA with the click algorithm. So it's the same as a Tobalaba, but it's not a Tobalaba. It's like a mirror image of it. And we decided to go for a derivative because we kind of found out that most utilities, again, they're a bit overworked sometimes, and they don't really want to have all the data out there in the open on a public chain. So right now for these labs, they rather have it on a permission chain and be a bit more in control and be able to actually see what's going on. So it's a bit of a conservative approach, but we kind of also understand it right now.
Yeah, probably what I can add here is also that I think a very strong argument that usually we use is that once we develop use cases on a very similar platform, that technologically similar to Tobalaba, once the utility decides or supplier decides to scale up the business model, it's pretty straightforward for us then to move that use case to Tobalaba, because basically you don't need to start from scratch, but you can basically, it's no longer a matter of weeks or months. Really, it's rather a matter of days than to put this to put that use case on Tobalaba and to make it much more scalable than it is in a secluded testing environment as we have it now.
So again, now this application would also work like it does right now on a Tobalaba. It's a different server, as you could say.
Okay. Okay, thank you. I will see if we have more questions. Nope, not for now. Okay. If there's anything else you would like to add before we finish.
Well, as we said, like if everyone's curious or interested in working with us on either one of the use cases or within the labs, everyone's happy to contact us directly through the mail here or also through EWF, of course, where we're happy to discuss and develop new use cases at any time.
Okay, and I think for the end we can say that we're very excited to see you at the Affiliate Forum at European Utility Week. So you're gonna have a booth with us together with EWF and some other affiliates, and that's really exciting. So looking forward to it.
Us too, yeah, really looking forward to it. Yes, thank you.
Okay, thanks a lot, and then we'll see you in a couple of weeks.
Thank you so much too.
Thank you for hosting.
Thank you very much.
Bye.
Bye.